Hello everybody, my name is Dmitry Figel and today we're gonna do another troubleshooting lab, this time about OSPF. The lab was designed by Andre Laurent for his webinar session, and during the webinar session we solved almost all tickets, so I decided to create my own. So let's just jump right into it. So here are the tickets. These 5 were created by Andre and these 2 are my own. So this time I decided to not to discover topology first as I did in the previous lab. I will just solve ticket by ticket. And I will investigate the topology while I will be doing it. Okay. But there are still some two couple things I would like to say about this topology. So here is our OSPF topology. So there are several things that I noticed when I first looked into it. So, for example, here we have area 66 and area 6. So area 66 is not directly connected to area 0. So this could be potential one problem. So we could solve it, I don't know, by virtual link or GRE tunnel. Another thing that I noticed is here there is no OSPF running here according to this diagram. So this is interesting. And another one here, we don't have area, but I would assume that it says that it is area 5. Okay. Let me clear that. Let's go to the tickets. Ticket number 1. Do not modify existing network statements on R6. Okay, I will take into account that later. And since it does not ask us to do anything, I will just check it. Well, we solved the first ticket very fast. Alright, let's go to the ticket 2. Make sure router 6 learns specific routes for prefix ranges or for that exist on R5. Okay, what prefixes we are talking about here? So it's obviously this one. It's obviously this 10/32 prefixes and this prefix, which is 10.1.25.0/24, right? Let's go to R5 and we do what? We do show IP route connected. Or yeah, okay. Okay. This one is not relevant right now. We'll take into we'll look into it later. So we have 5555. We have this prefix. I don't see 55 prefixes. I believe Andre forgot to configure them. So let me do this, show IP interface brief. Right, I don't see any 55 prefix. So let's create them as secondaries on maybe loopback 0. Okay. Okay, first loopback 0. and I will create these 10 loopbacks in the text editor. I will let it be 0. No, it's ticket 2. Okay. IP address 55, 55, 55.1 to 55 to 55 to 55 to 55 secondary 10 times. Alright, let's copy paste it here. Right. If we do show IP alias, we can see these prefixes. If we do show IP route, we also see these secondary IP addresses as directly connected. Right. Okay. Next. Make sure R6 learns specific routes. Okay. So we defined what routes we are looking for. So let's go to R6 to show IP route. Okay. This does not look good. So I see here connected loopback and another 2 connected interfaces. Alright, so the next thing I would do, I would verify neighborship between R6 and R1 and R6 and R4. Okay. I do show IP OSPF neighbors and I don't see any neighbors. Alright, the next thing I would do, I would ping our neighbor, 2 neighbors, ping 10 dot what dot 1 dot 16 dot 1. Okay, we can ping. Can we ping another one? 10.1.46.4. Okay, so we can ping both IP addresses. This means that layer 2 reachability between them is alright. Okay, so the next thing I would do is show. So we should investigate why we don't have neighborship between these 2 pair of devices. Right. So we do show IP OSPF interfaces brief. Okay. This one looks good, but I don't like this because we have here area 66 and on the diagram here it's area 6. Okay, and also here you can see that I can't modify existing network statements on R6. Okay, so I will do show run section router in R6. So we have these 2 neighbor statements. There are basically 2 solutions for that. If we can't modify existing network statements, we could specify more specific. We could enter more specific network statement in defined area, so as it won't be modification, it would be adding new one. We also could do this. We could go to these interfaces and turn OSPF using IP OSPF one area command, and that's probably what I'm gonna do. Okay. So okay, let's do this. Interface, I can copy it here, and IP OSPF process ID 1 area 6, and the same thing for another interface. IP OSPF 1 area 6. Okay. Let me also add this to the answers. So on R5 it was interface loopback 0. Okay. Oops. All right. Okay, good. And on R6, interface E00.46 POSPF1 area 6, interface E00.16 IPOSPF1 area 6. Okay. Okay, what I see now? Look at this log message. OSPF detected duplicate router ID from 10.1.46.4 on interface E00.46, right? OSPF detected duplicate router ID 666 from this IP address. We received a duplicate router ID, which is this. Okay. So let me show router ID on R6. I do show IP protocols. Here I can see router ID. We go to router 4, show IP protocols. Router ID is the same. Okay, let's investigate why. So do we have loopback interface or any other interface with this address? Okay, we have the loopback. That's why our router ID is 6666. Let's fix this. Okay, so I will shut down unused loopback, so not to cause any problems when we routing with this. Okay, so we shut it down. I will also add it to the solution on R4 interface loopback 6, shut it down. Okay. Okay, but router ID should not change afterwards. So let me verify. Show IP protocols. Okay, see, it's the same router ID. So I will go to the OSPF process and define it manually. Look, router OSPF 11. See here, OSPF 11, not OSPF 1. Remember that process number is locally significant for OSPF. Okay, we do what router ID command? Router ID 4444. Okay, And see, we need to clear IP OSPF process. Clear IP OSPF process. Yes. Okay, let me go to add this to our solution. Router OSPF 11, router ID 4444. Okay. Okay, let's go to R6 again and verify if our neighbors are okay. So to this we do show IP OSPF neighbors, and you can see I have two neighbors now, 1 and 4. Okay, 1 and 4 seems alright to me. Do we learn about the prefixes? We do show IP route. Okay, I see some inter-area prefixes, so that's good. Okay, see 1 loopback, 2, 3. I don't see loopback of the router 4. Which is strange. Okay. But we are interested in 555. Okay. Let me go to R5 and verify if we're running OSPF process on the loopback. I will do this show IP OSPF interfaces brief. Okay, and I do show run section router. Okay, so we redistribute connected subnets, but we don't run area here. So this one was also added by Andre later because there will be problems later. But let me I won't change it, but I add area 5 here. For loopback 0, IP OSPF 1 area 5. Oops, area 5. Okay. I won't add this to the solution yet. You will see later why. Okay, let's go to R2 and verify if we learn these prefixes. I do what? I do show IP route, and I don't see these prefixes. So are we neighbors with R5? Show IP OSPF neighbors. No, we are not neighbors with R5. Okay, we are only neighbors with 1 and 3. Can we ping 10.1.25.5? Okay, we can ping. Okay, let me verify if logging is on. Show logging. Debugging. Okay, let me do this. Show run section router on R2. Or maybe wait. Let me try show IP protocols. Believe there is some OSPF information there. Oh, okay. Yeah, look at this. Distributing external routes from number of areas in this router is 3. 2 normal, which is area 1 and area 5. No, which is area 0 and area 1 and 1 in SSA. Let's do the same thing on R5. I do show IP protocols. Can I do show IP OSPF? I believe. Okay, I can do show IP OSPF also. Okay, let me do the same command on R2. Provides very interesting output here. So show the command is show IP OSPF. Look at this area 5. It is an SSA area, and let's go to R5. Area 5. It is top area. Okay. So this is the problem. Why? Because to establish neighborship between two routers, the step flag should be the same. In this case, the SSA and stop areas are different type of areas, and they have different stop flag in the packet, in the hello packet, so they can't form neighbor relationship. I've also referred here to the tickets, to this one. R5 should learn a default route flagged as N2, not IA. So N2 is N2 routes exist only in NSSA areas, so this area should be NSSA. Alright. So on router 5 it is top area. This is wrong. Okay, I will do show run section router. Okay, and I will do the same thing on our router 2. Okay, area 5 in SSA, default information originate, no summary. On R5, do this conft router OSPF 1, no area 5 stop, area 5 NSSA. Okay, and you see here we have log message. Received hello from 2222 on Ethernet 0/0.25, indicating a potential network type mismatch. Okay, let me do this. Let me do show IP OSPF interface brief. This interface, look at this, state P2P, and I will do the same thing on router 2. This one, TR. So designated router, DR stands for designated router, can exist only on broadcast and non-broadcast network types. So it seems that on one side we have a different configuration. Let's do this to show run interface E00.25, and the same thing on the other side. Okay, you see here IP OSPF network point to point. I will add the same command on the other side, because when we set network type to point, the convergence will be faster. We don't have to wait for wait timer to expire like we do on on broadcast and non-broadcast network types. Okay, but you should use this only if on the shared Ethernet segment there are only two routers, so they are connected point to point essentially. Okay, let's go to R2. Interface E00.25 IP OSPF network point to point. Okay. Okay, what we did so far on R2, interface E0/0.25 POSPF network point to point, and on R5 we did router SPF1, no area 5 stop, area 5 and SSA. Okay. Okay. Let's look in if we have neighbor. Okay, show IP OSPF neighbor. We have 1, 3 and 5. Do we know about routes? Show IP route. We learn about 55, about 5, and 10.1.25.0 is directly connected. Alright. Let's go to R6. Show IP route. We have 5555, so that's good. And we have 55. And we also have 10.1.25. So it seems to me that make sure R6 runs specific routes. Okay, so this one is fixed. Okay, R6 should be able to telnet to 4444. Do not modify configuration on R1. Okay. Let's look in the routing table on R6. Show IP route 4444. Of course. Do we have default route? No, we don't. So we don't learn about 4444. Okay. Let me go to R4 and verify if we announce this network at all. Maybe we just don't enable, we did not enable OSPF on it. So I would just show running configuration. Network 4444. Area 0. So seems we have this interface in the area 0, so that's fine. Is this interface up? Show IP interface is brief. And you see this loopback 0 is administratively down, so we should do no shutdown, no shut. Okay. Let me add this to our solution. 3 on R4 the interface loopback 0, no shut. Okay. Let's go to R6 to we learn about 4444, and we learn about it from router 1. Okay, can we ping to 4444? We can ping. Can we let's do trace route just to verify. Okay, we go to like this, we go like here. The question does not ask us to modify path, so we just need to be able to telnet. Okay. Can we telnet? 4444. It seems that we don't. Okay. Let's verify telnet configuration on R4. I do show run section line VTY. Okay, so this is not correct. We should have transport input telnet, and we should either set password or do no login. I prefer doing no login. Okay. Okay. Line VTY 04. No login. Transport input telnet. You also see that there is no access class under line VTY. Let me copy paste this. Conf-t. Okay. Can we telnet now? Oops. Seems we can't. Alright. Let me do this. Let me verify if we have any access list here. Maybe inbound on maybe here inbound, maybe here inbound, or here outbound, or here inbound. It could be possible. Or we could have PBR or control plane policing. But I will just first verify if we have any access lists on R6, R1, and R4. Okay, let's go to R6 to show IP access list. Okay, we don't have any access list here. On R1, show IP access list. Okay, we have one. I really don't want to go into details right now. Why? Because there is no hit count for it. So it's probably not this access list is affecting our telnet, and let's do this. Let me go to R4, show IP access list. Okay, so this is really interesting. Why? Because we have here 8 matches. So it seems that this access list is indeed affecting our ability to telnet to 4444. Okay. Let me do what? To show run section telnet. Okay, we have class map match all telnet, match access group name telnet, class telnet drop. Okay. Class map. Let me do this. Show run begin control. Okay. And you see here control plane service policy input drop. Need to show run section drop, policy map drop, class telnet drop. Okay, let me change this. Conf t policy map drop class telnet no, I don't like this. I will just change access list so that instead of permit I will deny this, and I will insert it with sequence number as 5, so it will be applied before. Do show run section access list. Okay. 5. Okay. We deny TCP any telnet. Okay. Let me verify first if this affects anything or not. Okay, and 6 telnet. Okay, now we can telnet. So we indeed solves the problem. Okay. Let me put check here, and I will add this to the solution. Okay, we'll exit from the telnet session. What I did on R4 p access list extended telnet, and you probably are curious why I'm typing all this if I can just copy paste. Well, it's really practice for me to entering commands without mistakes. So for CCIE lab, speed is really important, so that's how I train. So if I could replicate my configuration as text file, it would be cool. If I could create a configuration file in the text file and then apply it to the router, it could also help me very much during the exam. So that's why I do this. I just rewrite manually instead of copy paste. So 5 deny TCP any go telnet. Okay, and I will also show you this. Show IP access list. Now I see that we have matches for this deny statement, so this permit statement does not work anymore because we overrode this with this entry. Okay, so okay, let's go to this. R5 should join a default route flagged as N2 and not IA. So IA stands for inter-area route and N2 stands for NSSA external. So this is redistributed route into the NSSA area. So type 2, magic type 2. Okay. So let's go to R5, and we do what? We do show IP route 0000, and we see default route type inter area. If we do show IP route, see here we have OIA, we need O and 2. So this is a really simple problem if you know the commands, of course. So let me go to R2. I will do show run section router. Area 5 and SSA default information originate, no summary. So no summary means that we have totally not so stubby area, totally an SSA, which means that we block not only, let's say, tab 5, but also LSA tab 3, and the only route we see is the only LSA we see, the database, is default route, which was advertised in the LSA 3, so that's why it's OIA. To change this, we will convert this area from the totally NSSA to simple NSSA. Okay. We'll do this. Conft router OSPF 1. Now I will delete it. No. And I will do here. Okay. This is problem 4. On R2, router OSPF 1. No area 5 NSSA default information originate, no summary. Area 5 NSSA default information originate. Okay. Let's verify config to okay. Area 5 and SSA default information originate. Okay, this should be okay. Let's go to R5 and I will do show IP route 000 again. Now we see default route as an SSA external type 2. If you do show IP route again, now we see this is ON2. Previously we saw this route as OIA. So this is also fixed. Okay. Let's go to one of the most difficult problems which we did not solve during the webinar session. Must be able to ping from R6 6666 to R5 5555 while making sure to take this path. Okay, first of all, let's go to R6. Can we ping 5555? We can ping. Can we ping with the source 6666 or loopback 0? We can't. So why is that? Remember what I told you in the beginning? Is that wait a second. So actually Actually, when we will solve this ticket, it will also affect this one. Let me explain this to you. Okay. So first of all, we can ping to 5555, but not from the loopback 0. Okay. So we can ping from here to here, but we can't do this from loopback. What does it mean? Well, usually it means that R5 does not know how to get back to 6666. Okay, let me verify this. I do show IP route. Actually, here we have default, so it does not matter. Let's go to R2, show IP route. See, we don't see. Let me do the show IP route 6666. Network not unstable. Okay, so this is the problem. So if you know OSPF good enough, you would understand why where is the problem. So area 66 is not directly connected to area 0, so we need to fix this. Alright, so and fix it creating virtual link, maybe here. Or here. Let me first create, if we create virtual link here, we would modify configuration on R1, and it was forbidden in ticket 3. Okay, let me do virtual link here. I will do what? I will set manually router ID on R6, because for to create virtual link we need router IDs of 2 routers. So what basically virtual links allows us to do, we create like tunnel here, which will be in the area 0, and this area 0 will be extended via this tunnel. So area 66 will touch area 0 via this virtual link. Okay. Right. Let's go to R6 conf t router OSPF. I don't know the process ID to show run section router. Router OSPF1 router ID 6666. Okay. Okay, and on R4 we set it manually. Okay. Router OSPF1 area 6 virtual link 4444, and router 4 the same thing, conf t router OSPF to show run section router. I don't remember process. Okay, it's 11. Okay, router OSPF 11 area 6 virtual link to 6666. Okay. Okay, let's go to R6 and we ping 5555 with source loop 0. Now it works. Okay, so this basically means that this route is learned by R2, and here we have default in this direction, so it is fine. For which path does it take now? We trace to 5555 source of loopback 0. Okay, they go to 1 to 2 to 5. So we go like this, 1 to 5. And we want to go like what? 1 2 3 5. We want to go like this. Okay. Okay, how can we achieve it without running OSPF on this link? So probably you remember a trick we did with EIGRP, so and PPP. So if the link type here is PPP, router 3 we will install host route to this one, and it will be as connected, and then we can announce it into OSPF or EIGRP. So let's go to R3 and we do show show IP interface brief serial 11. If you do show, let me do ping to that side, ping 5555. Okay, if we trace, it should go directly. It goes directly to 5 via serial link. If we show IP route, see here that this is directly connected. So by the logic, we should be able to do the same thing as we did in IGRP with like network statement. Then we will announce it into OSPF domain or IGRP domain in our case it's OSPF domain. Okay, let me verify if we have network statement for it. Show run section router. Okay, we have network statement 5555. Okay, the problem here is that it does not work. How can I show you this? Okay, show IP route 5555. It goes via 10.1.25.5. If we disable link, no, at first verify if we have neighbor. Show OSPF neighbor, show IP OSPF neighbor. We are neighboring with 3, so it's alright. If we go to R2, oh sorry, I forgot to add part of the solution. Okay, on R6 we do router OSPF 1, router ID 6666, area 6 virtual link to 4444 on what is this? And on R4 router OSPF 11 area 6 virtual link 6666. Okay, let's go back to this problem. I will disable this link and I will show you that R2 does not learn about this. Even though in the IGRP it would, in OSPF it does not. Okay. Okay. What can I do here? Okay, yeah, I disable link. And if we do show IP route 5555, did I shut down the link? Oh no, I did not shut down the link, sorry. One more time. Shut. To show IP route 5555. Network not in the table, okay? So it is not learned when we use network statement on R3. So, but it should work if we redistribute it. We do router OSPF 1 redistribute connected subnets. Set this to the solution on R3 router OSPF 1 redistribute connected subnets. Okay. On router 2. Okay, now we learn it as external type 2. Okay, let me enable the link again. 0.0.25, no shot. Okay. Loading to full, done. Okay, you see that we prefer intro area. So let me clear this diagram a little bit. We consider this segment. So this route here is let me use red color. Okay. This one here. Here we have area 5, and R2 learns about it as O, because here we have also area 5 and here we have area 5, so it is intra area, meaning inside the area route. And in other parts is external type 2. So, and from R3 here we have redistribution, and third here is O, and this route here is OE2. Okay, so and why it can't be solved? Because we can't enforce preferring E2 route over intra-area route. It's just not possible in OSPF. And we can't do any, like, I don't know, summarization or whatever, because R2 and R5 are in the same area. So that's why. Okay. Again, so there are a couple of rules in SPF, like the preferable route is O, then this is intra area, meaning inside the area. Then we have ORA, which is OSPF inter area, so meaning between areas. Then we have E1 and 1, and then we have E2 and 2. Between these there are a lot of corner cases. Really hard to remember this all by heart, and I don't want to make a mistake, so I won't tell you all of these scenarios. So like between these two, we first look if the ASPR is in our area or not. Then we compare metrics, and we like could choose for this one. We compare metric, forward metric. So there are a lot of stuff here. So in order to learn this, you need to read some book. I actually listed some resources for SPF here in the post-webinar discussion. I believe it is this. So I recommend it if you really want to know how SPF works. This book, Routing TCP/IP Volume 1 by Jeff Doyle, or RFC, or you could also use Cisco technology documentation. It's also really good. So, but believe me, it's really hard to remember all those details which are preferred over which. But in general, all intra-area routes are always preferred over inter-area routes, which are always preferred over any type of externals. Okay, let me clear this. So that's basically why we can't do anything here. However, first of all, I can delete this. Okay, let it be like this. Or okay, I will reopen. Okay, so it does not say here that it should be area 5, I just assume it, but I will do a small trick. I will leave it in area 5, but what I will do, I will just assign a different process number for it. Okay, so we're running here process 1 for this. Here we have process 1, here we have maybe process 100. Okay, so this, and Then we also will do redistribute connected subnets. So as process number is 100, it will be isolated from other OSPF domain. It still will be in area 5. Instead, we also will redistribute it as redistribute connected, which will announce this route as N2. And remember that here we have ABR, and it will perform this route is announced in LSA type 7, and ABR will perform translation from type 7 to type 5. So there are some more details for it, but I don't really want to discuss it because it's really advanced stuff, and unless you're studying for CCIE, you actually don't really need to know that. Okay, so let me do this. Okay. Show run section router. Show run interface loopback 0. Okay. So I will change here process number to 100. Conf t interface loopback 0 IP OSPF 100. Let me do this first now. IP OSPF 100 area 5. So technically it's still in area 5, but it in different process number, so it should not affect anything. We can't advertise this route to R2 as in the same area, so but we redistribute connected, alright? Okay, let me add this to the solution. On R5 interface loopback 0, no IP OSPF 1 area 5, but IP OSPF 100 area 5. Okay, and we take a look at the R2, and it will do show IP route 5555. Okay. Okay. So this one is now redistributed here. In an SSA it becomes N2 route. R2 receives it, so it goes here. And we also have this route here directly connected, which is then redistributed on R3 as redistribute connected subnets and goes to R2, and this route is E2 route. So which one is preferred in this case, E2 or N2? Let's take a look. Oh, we see here it's N2. So there are a couple of different ways to solve this. So for example, you could do one crazy thing like this router OSPF 1 compatibility compatible FC 1587, and so we'll do show IP route again. Now you see that we prefer route from 3 over NS external. So this one is alter FC, which were used by default in 12.4 code, and it basically like allows us to prefer E2 over N2 if the metric is the same. Okay. but later we had new RFC. I believe it's 3501. Maybe I'm mistaken. I don't remember exact number. So like it changed its behavior so that we will prefer N2 if the metric is equal. But I will disable it because it's really a rare command. So and let me do this. Let me show you this command in the documentation. So I have here disco.com//go to go to the documentation page, www.disco.com/go/documentation. Okay, and we select networking software 15.5 and 15.5.2t. Okay, and I refer to what? To command reference guide for IP routing OSPF command reference. And A through IP OSPF. Here, this one, compatible RFC 1587. Okay, you see I was wrong. The RFC was 3101. Okay, so it says that to replace this compatibility for route selection in NSSA area, border routers use this command. So they don't provide you any details except of RFCs, so for more details you should see Appendix F of this RFC. Okay. Okay. And I'm looking for Appendix F. Okay. So here you could read the differences about N2 and E2 route selection. So I would just for your information, this command is, I believe it's overkill and it's hard to command to remember, because maybe you will do this one instead of the other one and it won't change anything. It will change another behavior. So this is one solution, not the best one, but I just wanted to show you. Okay, I will remove this no compatible RFC. Okay, let me do this to show around section router. And okay, now I will remove it. Okay, what other solutions do we have? We can influence the metric. So even though This route is distributed here with metric 20 by default because it's E2 type. Here we have by default forward metric 10. Here's the same thing, we have forward metric 10. Forward metric means metric how to get to ASBR. And here we have redistribution as N2 also by default is 20 metric. So we could change the metric here. Either forward metric or end metric. What can also we do? We can let me verify if the behavior is restored. Okay, we prefer N2. So we can influence metric here. We can do some tricks with summarization. I will show you in another problem here today. What else we could do? We could do this. By default we distribute this as E2 and I will redistribute it instead with E1. This one will be N2 and this one should be preferred. Okay. How to do this? We go to, let me verify config here real quick. Conft router OSPF1. Redistribute connected subnets to metric type 1. Okay. Let me go to R2. Now you see that we prefer type external 1. So this route is preferred, and I will probably keep this solution because I like it. We go on where we did some changes. We did changes on R3. On R3 here, metric type 1. Yes. Metric type 1. Okay. So E1 is preferred over N2. So the problem should be solved right now. Let me double check this. We do trace route and we go like this. We go 1 1 2. Oh. Okay, now it's interesting because we go like this. We go 1 4 3 5. Okay. Let me verify why. On R2 I would, on R1 show IP route 5555. Metric is 34. 34. Why is that? Okay, let me do show IP OSPF device brief. Cost here 4. So here we have cost 4. Here we redistributed with metric 20, and here it seems we have 10. Okay, so it will be 4 plus 10 plus 20, 34. Indeed, it's 34. And but we want to prefer this route. How can we do that? This cost is 10. We should lower cost of these links. Okay, let me go to R2, show IP OSPF interfaces brief. And for these interfaces to 3, I will change cost to what? To 1. Okay, const T. Do this in the text editor on R2. Interface is 0/0.23, and we do what? We do OSPF cost 1, and then we do this for two other interfaces on R2. Okay, now we should prefer route. Okay, you see now we have metric 31 via router 2. Let's do the trace route. So now we prefer the route like this. We do trace route from router 6, and we go to 1 2 3 5. Oh, 1 2 3 5. And the question was 1 2 3 5. Okay, and can we ping 5555 source loopback 0? We indeed can. Okay, so this problem is solved too. Okay, now let's go to my own tickets. So just before we go to that, so this N2 E2 E1 N1 stuff is really complicated. So if you really want to know OSPF on such in such details, you need to read some book or some other resources, because it's really complicated. It's exactly why OSPF is in my top 3 list of the most difficult core networking technologies. Okay, so okay, ticket 6. R6 should go to 4444 via the path 6 1 2 3 4. It is allowed to change configuration on R1 for this ticket. You remember in ticket 3 it says do not modify configuration on R1, and now I am allowing to do that. Okay. Okay, so let me draw this. So we want to go like this. 1 2, 3, 4, like this. Okay. Let's first verify how we trace right now. Okay, so you go like this right now, so you go like this. Okay. It's also this problem is really not that difficult, I would say. But in order to solve it, you really need to know core basics of OSPF. Okay, so let me show you why it is a problem from R1 perspective. So we want to, from R1 we want to route like this, and right now we route like this. The problem here is that R4 and R1 here, this is they are in one area, area 0, and here we have area 1. Area 1. Why is that the problem? Well, if we learn here we learn this route as O, which stands for intra area, meaning inside the area, and this route will be learned as what? As OIA. So basically we are traversing area 1 here and go back to area 0. So in OSPF this is not possible. So routes inside the area will be always preferred. So, and let me show you this. What I will do, I will go to in R1 to here 3 interfaces, and I will increase cost to 1000. Okay, and I will show you that R1 won't reroute to R4. Okay, how can we do that? Okay, interface E00.14 IP OSPF cost 1000, interface E00.114 IP OSPF cost 1000, interface E00.214 IP OSPF cost 1000. Okay, and now we go, oh no, we just show IP route 4444 again. Okay, this is a little bit funny. Why? Because here we remember that here we have virtual link VL 0. Okay. So now I increased cost here, and we reroute like this. But why does it says that we're intra area? Okay, can we do trace again? No. Yeah, we go to 6 and 4, but we don't have any virtual link on R1, don't we? If we do show OSPF virtual links, no, I don't have. So it's really interesting behavior of virtual links. You should be careful with that. So let me, what can I do here? I really don't want to mess with this virtual link. It should not route like this. So I will go to R6 and I will go to a router OSPF1 to show run section router. Okay, and I will add cost here. Router OSPF1 cost. How it's done, I don't remember. I believe to change cost of virtual link I have to change cost of underlying interfaces. Show IP interfaces brief. Show IP OSPF interfaces brief. Virtual link cost 20. Okay. Yeah, I would like to change it to this. I will go to R6 interface E00.00.46. We still will prefer that route because it's, but still let me do this. IP OSPF cost 10,000. Okay. You see, this design begins to be really complicated. So we have virtual links and other stuff. So let me go to R1 again. Do trace. We go directly to 4. So if you do show IP route 4444. So you see, even though the metric here is 1000, so here 1001, we still prefer it if you go like this, and the metric could be, I don't know, 30 or 40. So see, the metric doesn't matter because this route is in the same area as R1 is. So, but there is still a way to solve it. So again, this is O route, this is OIA, and O is always better than OIA. Here is my solution how to solve this. What if we do virtual link between R2 and R4 over this area, and we will have this like a virtual link area 0. So basically R2 will see this route over virtual link. Thus, if we so R2 sees R4 as O, it advertises it to R1 and it will be O, and then we can compare metric. Alright? Okay. If we do on R2 show IP route 5555, no, 4444 right now. Type is intra area. So right now the route on R2 is learned like this. Okay. I will create here virtual link. Show run section router. Sorry. Okay, conf t router OSPF1. Let me also do this. On R6 interface E00.46 P OSPF cost 10,000. Okay, router OSPF1, a router ID 2222, area 1, virtual link to 4444, on R4, conf t to show run section router OSPF 11, area 1, virtual link 2222. Okay. Now we look in the routing table of R2, show IP route 4444. And now you see that this route is learned from 3 as intra area. So technically it's learned via virtual link, but in the routing table you can't show that it's learned via virtual link. So it's learned like this, and the type of it's O. Okay, intra area O. Show IP route pipe 4444. Pipe include. See, O. And R1 should be able to see that route from router 2. Yes. Route from router 2, metric 22. And if you do show IP route pipe I4444, see, now it's O. If you do trace from router 6, trace 4444, we go like this. 1, 2, 3, 4. Which is exactly what we needed. Alright, so that's great. We solved the ticket, this one. Let me add solution to our text file. And let me undo this config. I'm not sure. So even though it said here that it is allowed to change configuration on R1, I'm not sure if the metric will be okay here. Okay. So maybe the metric here, which is 21, I believe. No, I really should keep it, because on here on one link it was 4, and for loopback we have 1, so it would be 5, and here we have 21 or something. So 4 will be better. So yeah, we can't do this ticket without this, without changing configuration on R1. Okay. On R1 interface 00.14 OSPF cost 1000 and 1 2. Then on R2 router OSPF 1 area 1 virtual link 4444 router ID 2222 and on R4 virtual link 2222. Okay. Now this solved, we have only one ticket left. R6 should go to 3333 via pass R6, R1, R2, R5, R3. Okay. R6, R1, R2, no, like this. Okay. Let's check how we do it now. Trace to 3333, and we go like this. Go like this. Okay. So what do we do? First of all, we go to R2 and we do show IP route 3333. Okay, so now we have basically the same problem. So 3333 is in the same area as R2 and R3 because we have network statement, network for it. Do we show run section router? We have network statement for it in area 1. And from R5 it is redistributed it is what? It is redistribute connected, and R5 sees this one as directly connected, and then it is redistributed into OSPF. Okay, so but here on the diagram this interface is not required to be in area 1. Okay, so I will just change it. I will delete the statement because we still have a redistribute connected. Okay, so because this is not on the diagram, I am free to change it. Okay, so I will do this router OSPF1 no network. Okay, now we go to R2 and we see that route as what? Now you see that this route is seen as external E1, and from R5 it should be seen as N2. Let me verify this real quick. So I do this. I do show IP OSPF database for NSSA external and link ID is 5555. Okay. OSPF with router ID is this. advertising router is 5. So we have this prefix in LSA database, in OSPF database, so it seems alright. Okay, what do we do now? Because for fifth ticket we preferred route 3 to 5, and now we want to prefer route from 5 to 3. We already changed this to E1. What can we do now? We should revert it back and announce it as here as N1 and here is E2. No, I have better solution. So let me do this. Because here we redistributing it on R3, redistribute connected metric type 1 subnets. I will do this. I will do summarization to 3.3.3.0/24 and send it here. So we will have two prefixes. Here is summarized E1 and here is specific N2, and specific of course should be preferred. Okay, so how do I do that? First let me add this to the solution. On R3 router OSPF1 no network 3333.0.0.0.0 area 1. Okay. Okay. conft router OSPF1. We want to do summarization on router 3. We do this summary address 3330 and mask 255.255.255.0, and we don't need any of those. I will add it to the solution here. Okay, let's verify this. We go to R2 and you see previously we learned from 3 as external type 1. What do we see now? You see that we learn it as NSSA type 2 from router 5. And if we do show IP route I3.3, okay. You see that we have E1 route which is summarized and N2 route which is specific. So this one will be preferred and via 5. Let's go to R6 and we do trace again. And what we see now, we go like this, 1 2 5 3, and in the ticket it say 1 2 5 3. Okay, so it seems that we solved this ticket as well. Okay, alright, so it seems that we solved all the tickets, and I will do this. I will just double check every ticket if we did everything alright or not. Maybe we broke something. So we'll do show IP route for ticket 2. We see 5555. we see 10.1.25 and we see 55 networks. Okay, and you see here this route is OR external 2 because this route here is N2 and then on R2 there is 7 to 5 translation, and this route becomes E2. Okay. Okay, so this seems okay. Must be able to telnet to 4444. 4444. We can telnet. Okay. R5 should learn default route flagged as N2. R5 show IP route O N2. Okay, this is perfect. Must be able to ping from 6666 to 5555. Ping 5555. We can, if we do trace 5555 from source loopback 0, we go to 1235. 1235. And I did ping wrong because I have to specify it from loopback 0. Okay, this is fine. On R6 should go to 4444 via the path like this, 4444. We go to 1234. 1234. Okay. And the last one, if you do trace to 3333, you go like 1253. 1253. Okay. So guys, it seems that we solved all the tickets, and thus I should conclude this video tutorial. Thanks for being with me during this tutorial. I really appreciate it. If you could give me a like or give me just some comment what I did wrong, what could you do better, I mean in terms of solution and also in terms of video recording, if you have some advices, any comments, because it's just the second time I do video tutorial, so it's really new for me. I'm still learning how to do it. So any suggestions, any advices, any comments, feel free to reach to me. And okay, so so that's basically the end of this session, and thank you again, and I hope I will see you in 1 week when we will have I believe that lab about IGP redistribution. Actually, don't remember, let me double check it. Okay, here we check the timetable. Yes, so the next session is IGP to IGP redistribution. Will be very challenging and fun, and I will see you in 1 week after I record the solution for the next lab. Thank you, take care, bye.